Let's recapitulate. Displacement, it is change in position. Okay, like we write it here. Displacement is change in position, final position minus initial position. Okay, we'll get back to it, but displacement is related to the velocity by average velocity. Remember, those brackets are to say average times time. Okay, now if we have motion along one direction, then we usually write the displacement in terms of x, for example. Instead of writing the arrow, we are going to write it as an x to tell us that all the motion is along that same direction x. Then my displacement is change in x, delta x, which is x final and minus x initial. Now if we write it down along one direction like this, the positive sign is going to mean direction. It's going to mean the displacement is along a particular direction, and the negative sign is going to tell us the displacement is in the opposite direction of that. So plus is pointing in the same direction as the positive x, minus is pointing opposite to the positive x. Now displacement in 3 dimensions is really a displacement along the x, a displacement along the y, and a displacement along the z, all together. Remember, displacement is a vector. What we wrote here for the x, we could have written it for the y, of course. Displacement along the y would be delta y, y final minus y initial. Okay. Remember, distance is a scalar. The magnitude of a displacement is a scalar, but it's not necessarily equal to the distance traveled. It is a distance, but not necessarily the distance traveled. Be careful about that. And then, okay, speed is also a scalar, like distance. Neither one of these are used often in making calculations. They might be a final result. You might be asked to find the distance traveled, but you are not going to use distance most probably in the calculation. You'll be using positions and displacements. Now, velocity. As I mentioned in the previous slide, it is displacement over time. That's the definition of velocity. That's the most general equation for velocity. That's what you need to use most of the time if you need to find average velocity. When you have constant acceleration, you might be able to use the equation that says average velocity is equal to VI plus VF over 2. But this, you can use it only when A is constant. Be careful about that. Okay, so saying that it is displacement over time is saying it is change in position over time. If our motion is restricted to one direction, for example to the x-axis, then the velocity along the x would be the displacement along the x over time, which is change in x over time, x final minus x initial over time. Now, this was talk of an average velocity. What about an instantaneous velocity, velocity at an instant? Strictly speaking, an instantaneous velocity does not exist. But really, it becomes instantaneous when this delta t becomes very small. Or mathematically speaking, instantaneous velocity is the velocity that we have when we go to the limit of delta x over delta t, the limit when delta t goes towards 0. So the smaller delta t gets, the more instantaneous our velocity gets. So an instantaneous velocity is an average velocity over a very, very short time. Okay, since velocity is a displacement, it's going to need a time span. So the time span might be very small, but we need the time span. When the time span is very small, we have what we call instantaneous velocity. Okay. Last thing is the acceleration. Again, the average acceleration over a period of time delta t is the change in velocity over that time. Vf minus Vi over delta t. If our motion is along one direction or along x, for example, my acceleration is going to become change in the velocity along the x over delta t, or Vx final minus Vx initial over delta t. Again, like what we said for velocity, we get an instantaneous acceleration by making the delta t go towards 0.